Happy day, students. So let's start with the next class. If you remember that we finished on this particular question only in our last class, and what we found in this particular question, we found that what is the position at which we are going to get first minimum. Okay, and we considered that here we are going to get maximum. Which maximum? I told you last class, if you are going to see the paths traveled by the wave which is starting from S2 is S2O. Same way, the paths traveled by the wave from S1 to interfere at O is S1O. Now since this is 1 meter, this is 1 meter, and this is common distance between them, so this will be, we can say, the distance is root over 1 square plus x square, and this is also 1 square plus x square. That means both the waves are traveling the same distance. So here path difference is 0. If path difference is 0, phase difference is also 0. And we know that whenever we are going to search maxima, that is maximum intensity or constructive interference, we equate this delta x with n lambda. Okay, because we say that whenever we are going for constructive interference, the path difference will be whole number multiple of lambda. Okay, so here n is whole number multiple. Now what is coming here? 0. It means n is 0. Okay, so this will be called as 0th maximum intensity or 0th constructive interference, where path difference is 0. Okay, now since the question is asking us the first minimum when you are going to cross O, let's say this one, at this particular point we say that this distance is y, at this point we are going to get first minimum. Okay, so if at that point we are getting first minimum, then what we have to do? We have to join that point with both the sources by saying that the wave is traveling in that particular path only. Okay, so let's join this one. Okay, now we can see clearly from the diagram that S2y is actually more than S1y. That means this is traveling more than this one. But since this distance is very large as compared to this, as compared to the distance between the two sources, then we can consider that S1y and S2y are actually parallel. S2y is parallel to S1y, as I explained you in the last class. Then how to find the path difference then? It is S2y minus S1y. How to find it? So what is the method? The method is from the smaller one. This is the smaller one and this is the larger one. From the source, drop a perpendicular onto that one. And since the two are parallel, okay, then we can say now that My and S1y is equal. As I explained you this in our last class. Okay, when the two sources are very close and you are watching from very far distance, then the rays which are coming to you or the waves which are coming to you will become parallel to each other. And if you want to know that how much larger is one from the other one, drop a perpendicular from the smaller one onto the larger one, and then this and this becomes equal. So what is that? S1y will be equal to My. Then what is S2y minus S1y then? When we are saying that S1y is equal to My, that means here I am going to put My. So S2y minus My will be what? S2m. Get S2m over. Okay, this will be S2m. Alright, now we have to find what this S2m is. So what we are going to do, assuming that this angle is theta. Okay, this is the right angle triangle, you can see. This is the right angle triangle, this is 90. Okay, if this is 90, that means this is hypotenuse. Okay, I want this value. So I can say sine theta equal to opposite by hypotenuse. Sine theta equal to opposite by hypotenuse. So this is what we are saying is delta x for us. This one. Okay, so what we will get? Sine theta equal to delta x by 2. Okay, and delta x here, delta x will become 2 sine theta. So path difference here is 2 sine theta. Okay, now here we are getting 0th maximum. So and here will be first minimum. So if it is first minimum, then the path difference should be equal to lambda by 2. Okay. For destructive interference, path difference should be odd number multiple of lambda by 2. Okay. And you are searching the first one. Why first one? Because here we got 0th maximum. So next will come what? First minimum. So what should be the path difference here? Lambda by 2. So you will say here fine, this should be lambda by 2. Okay, now what is lambda? It's given to us that frequency is 600 Hz, speed is 300 meters per second. So lambda, which is V by F, let's put it over here, V is 300 and F is 600, so lambda is coming 1 by 2. We'll put it over here. Lambda is 1 by 2. So 1 by 2 by 2 equal to 2 sine theta. So what we are getting? Sine theta we are getting as 1 by 8. Sine theta is 1 by 8. Okay. So now what we can do? We can find out this position y as well as we got theta value already. Okay. Now this theta value is what? Now check. If this is theta and we already said that S1y and S2y are parallel. If I draw one more line from here, that will also be parallel. If I say this is point P. Okay, S2y is parallel to S1y, so as EY, that's also parallel. Okay, now see again, this angle is theta, this angle is 90, then what is this angle? In this right angle triangle, that has to be 90 minus theta. Okay, now if I draw a horizontal line, this is vertical, this is horizontal, this is 90 minus theta, that means this angle is theta. And this line are parallel to each other, and this line are parallel to each other. Okay, this and this are parallel because this is horizontal, and this are parallel. Or in fact, this and this, all three are parallel. So this angle also will become theta. Okay, so if this angle is also theta, in this triangle you see, which is POY, I can write tan theta equal to y by d. Okay, tan theta equal to y by d. Now, if this is very large, then we can equate sine theta with tan theta. Okay, we can equate sine theta and tan theta. If theta tends to 0, then we can equate sine theta and tan theta. We can say both are equal. So remember, if this distance is given very large as compared to this, we can equate it. But otherwise, what we did in the last class, same thing we should do. So remember that always, if it is very large, then you can directly equate sine theta and tan theta. How? You can directly write sine theta equal to tan theta. Now sine theta value came what? What was the sine theta value? Sine theta value is here, you can see, this is delta x by the separation between the two sources. So right now, if suppose I say this is d, then sine theta I can write as delta x by small d. Okay, and tan theta value is y by d. Okay, so y value will come as delta x capital D by small d. But remember, this will be done only when theta value is very, very less or very, very small. When can it happen? When you say that the screen and the sources are placed at very large distance as compared to the distance between two sources. Then you will use it. Otherwise, we will get sine theta value as we have done over here. Sine theta we calculated, and from here we will calculate tan theta also. How can we do so? Very simple. If sine theta is 1 by 8, we know that this is theta, this is 1 and this is 8. Then only sine theta is 1 by 8. So what will be this value? This value will be 8 square minus 1 square. That is root over 63. Okay, so tan theta will be what? Tan theta will be equal to opposite by adjacent. That is 1 by root over 63. Okay, but tan theta is also y by d. So what will be y value? Y value will come as d by root 63. This is how we calculated in our last class also. Okay, this will come d by root 63. When? In which case? When sin theta is not very small, we will do this. But if sin theta is very small, directly equate sin theta with tan theta. Okay, now suppose we are going to calculate the position of first maximum. We are going to calculate the position of first maximum. Now what happens over here? Here you got 0 path difference. Okay, here you got lambda by 2 path difference. When you go ahead over here, then you will be getting path difference as lambda. Path difference is increasing as you are going away from that. So for maximum intensity, you should be having how much path difference? Lambda. For constructive interference, path difference should be lambda. So in that case, what we will do? This thing is, we will again write in place of lambda by 2 here delta x. Okay? Because this triangle is same only, there is no change in it. Only thing is this will be joining over here. Okay? Some other point we will say this as m or n. Then you will say the path difference is S2n minus S1n. Okay, again we will say S2n and S1n are parallel. Same thing, same kind of a diagram. And again we will say delta x equal to 2 sin theta. Okay, no change in that. But what will change? Delta x, because this time we are searching maximum intensity. Which maximum intensity? First maximum intensity. Why first? Because it's coming after 0, this is first minima, then first maximum. Okay, so here is lambda equal to 2 sin theta. Okay, now what is lambda? Lambda is 1 by 2. So 1 by 2 equal to sin theta. Okay, so sin theta is 1 by 4. So we got already the angle at which we are going to get first maximum. Okay, but this again angle is not very small angle. So when the angle is not small, we will calculate tan theta again. What will be tan theta value with the same kind of a triangle? This 1 by root over 4 square minus 1 square. 16 minus 1, that is 15. That's equal to y by z. What is y now this time? This is y. The position of first maxima from O. Okay, what's going to come then? Y will be root over 15d. Okay, is that clear? So this is the way we are going to calculate the position of first minimum and first maximum. Now, other question that can be asked from you in this one, that how many maximums are possible, how many constructive interference are possible along this line? How many are possible? Let's see how to find that. We may say that infinite are possible, but infinite is not the answer. So see, I am again making, this is S1 here, this is S2 here, and the separation between them is 2 meters, and our wavelength is half meter. And this is how the listener is. Always remember that the maximum distance at any point between the two waves generated by S1 and S2 can only be equal to the separation between them. Okay, again I am saying maximum distance or maximum path difference between two waves interfering at any point is equal to the distance, the minimum distance between two sources. Okay, this is very important point, please note it. Okay, so what is the maximum path difference